Hey folks, welcome to another developer blog video. I want to give a shout out to the audio programmer for the opportunity to do this guest post on his channel. In this video I'm going to be talking about how to do certain types of animation in your project. So let's say you finished your GUI and whatnot, and it's just very static. Like you can move your knobs and whatnot. But it doesn't do anything other than that. So what we want to make happen is, give a little interactivity when you mouse over stuff. So when you mouse over a button and it, like a little halo highlights around it or something like that. That's what we're going to try to do here. We're going to do something similar to that. And there are two different approaches you can use to get this functionality to happen in your application. And I'm going to talk about the first approach that I've found is pretty effective in this video. In another video, I'll demonstrate the second approach. All right, without further ado, let's dig in. As we did in the previous video, we're going to start with our sandbox project. We're going to make a new branch from the master branch. This way, we have a clean slate to start our little test projects from. All right. Now let's dig into this. Okay, we're on our animated component. All right. Now let's pretend we have like some kind of animated component, like a little button or whatever. And when we mouse over it, when our mouse interacts with it, some kind of graphical animation happens of some kind. Maybe there's like a little shadow that slowly appears, and then when your mouse cursor leaves it, the shadow kind of fades away. So let's set up our project thusly. All right, we're going to make a struct. It's going to be called animated component. All right, it's going to subclass component. I chose a struct because I want everything to be public for right now. I don't want to have to deal with public or private member getters and setters and all that nonsense. This is going to be nice and simple. So first things first, let's just get it on the screen, make it look like it's something. Okay, so to do that, we need to override our paint method. Right. And let's implement that. Void animated component paint. Right. Give ourselves the parameter to operate on. Like that. Just a little space bar. All right, so first thing we need to do is g.fill_all, and we use colors white. We want a white background, and we're going to draw just a rectangle around it. All right, g.setColor, colors black, right, and then g.drawRect, just so we know where we are on the screen. Get local bounds. All right, now we're not going to see it until it's actually like added as a child somewhere. So let's add it here. I'll make a child animated component comp. All right. We're going to add it as a child here. Add and make visible comp. Right. And then we'll set the position. Comp.setBounds. Get local bounds. Width, size, keeping center. We'll do 400 by 300. All right. Now, if we run this, we're going to see just a white rectangle. We're going to see just a white rectangle with a black bar around it. Let me get rid of this fill all. And there we go. All right, awesome. Okay, so the next step is to figure out our intended behavior. Now, what we want to have happen is when the mouse cursor goes within the bounds of the component, we want some kind of animation to happen. For this example, I'm just going to make it have some kind of color change slowly happen. So in order to do that, first we have to detect when the mouse cursor goes into the bounds of our component. So to do that, we need to override mouse enter. What's going on? Mouse event E. And we need to, if we want that effect to disappear when our mouse we need to have the event disappear. We need to have the effect go away when the mouse leaves the bounds of the component. All right, so void mouse exit event e override. Okay, so let's just get those two things to happen. All right, and just to demonstrate this behavior, we'll just make it say this. We'll just make it say this. We'll keep an eye down here. All right. Okay, so now we know that our mouse messages are showing up in the right place. Now, there are two ways to accomplish this that I know of that work pretty well. I'm sure there are others. So I'm going to explain the first one and talk about what happens. So the first thing that we want to have happen, just to demonstrate what's going on, kind of give you an idea of how you can use your mouse events to propagate changes. First of all, make them call repaint at the end. And then, change some property. Like, let's say we want the color to be drawn to be a different color. Okay, so we'll add a all right, color, background, color, right? Go like that. And we'll set it to alpha all the way up, and we'll just make it red. All right, so we did alpha at max level, red at max level, RGB, so this is green is 0 and blue is 0. All right, like that. Okay, so now what we can do, we can say when the mouse enters, we're going to change what background color becomes. All right, background color equals color. All right, we'll make it blue. We'll do that. Okay, so 0x full alpha, no red, no green, full blue. All right, and then when the mouse exits, we change it back. For full alpha, full red, no green, no blue. All right, and our fill all is going to be background color. Okay, let's run that. Let's check it out. All right, so it's red, and then when our cursor goes into it, it changes to blue like that. Now, so what we want to have happen is when our cursor enters it, we want it to slowly change from one to the other. Now, how do we make that happen? So one way to think about this is if you imagine something that's refreshing 60 times a second, and that's not actually what happens here. The computer says, does this need to be repainted? Yes, it does. Okay, and then once it's done, it's not going to repaint again until you tell it to repaint. So that means we need to have some kind of way to get the computer to keep repainting the screen as long as we need it to keep repainting the screen. All right, I'm going to introduce a little utility function class that we can use. And what it does is it's based off of the timer class, and it lets us use the ability to call a lambda after a certain period of time. If you're not familiar with what lambdas are, they're just little anonymous functions that you can call whenever you need to, and they don't have to be related to the class or whatever. I'm sure there's going to be a link in the description that points to the cppreference.com page explaining what lambdas are. All right, so here's our little class. Okay, all right, here's our guy right here, this delayed one-shot lambda, in that we're going to just call this singular function a single time. So the way this works is it's derived from the timer class. So that lets us, start a timer at a specific interval, and we have a member that's that's a void function that takes no arguments. So what that basically means is you have a function that doesn't return anything and it takes no arguments. Okay, this gets passed in as the argument. This is the lambda that I was talking about. It gets stored as the private member. Now what happens is, say we set this to 500, basically a timer starts running, 500 milliseconds later, this timer gets called, and what happens is the timer deletes itself via this code, and then it executes the lambda that you passed in. All right, and when this executes, or when this deletes itself, it calls the destructor, which calls stop timer, so it stops responding. Okay? The way this works is you do something like this. You would type something like new delayed one-shot lambda. 500 milliseconds later, I want this thing to happen. Okay? This is the lambda syntax. Here are variables that are going to be captured from the surrounding scope, meaning like we could be capturing this E, we could be capturing background, we could be capturing the animated component itself. Here are our parameters, and if you remember, this is a std function with no parameters, so this must be empty. And then here's the actual body of the lambda. Let me make this look a little bit easier. All right, so we're going to capture this. 500 milliseconds after the mouse cursor goes into the component, we're going to see a debug message that says the bounds of our guy. Or actually, we don't even need to do that because this is captured. It becomes all the functions and whatnot that exist on this object are available to us. So even though I could type this, I don't need to. I can just say get local bounds .toString, like that. So let's check it out. Actually, we'll make that 1 second. All right, here we go. There we go. You see that? You see that delay? We'll do that one more time. Cursor in, and the bounds pop up. All right, so we have something that can be called at a later time over and over and over. Okay, so let's take this to the next step. All right. Let's say that what we need to have happen, we need some kind of counter. Say we want this to appear like, say we want something to change its value over the course of 10 steps, all right? We're not sure how fast those steps are going to happen. We just know that it's going to take 10 steps, all right? So we'll just do const int num steps equals 10. Actually, I can do it like this. All right. Now, what we'll do when the mouse cursor enters the function is we'll start some kind of one-shot lambda that's going to call another function that's going to increment the count. All right. So we'll just do void increment count. All right. That's going to take some parameter like this. It's going to do int C for count, like that. All right. So what we're going to do is we're going to do, first we're going to fire it off. Okay, so the new delayed one-shot lambda. We'll say we're going to do this every half a second. All right, and then our lambda is going to capture this. It has no parameters. And it's going to call it's going to call increment. Oops, let me save this so it shows up here. It's going to call this increment count, starting value of 0. Okay. Now, what's going to happen when we increment count? All right, increment count is going to check whether or not the value we passed in is less than num steps. Okay. We go like this. We go void animated component increment count. All right, slowly building this up, slowly building up our functionality. We're going to do if C is less than num steps. Okay. If the value we pass in is less than 10, then we're going to do this again, but with 1 added to C. All right, so we'll go C++ like that. Heh. I'll make it easier to understand for those of you that don't follow PostScript and prescript, postfix and prefix operators. Okay, we'll go like that. That's going to increment it. Then we go new delayed one-shot lambda. Okay, 500 milliseconds later, do the same thing we did before. All right, we're going to capture this. We're going to capture C, because if we don't, once the value of C, once this function finishes, the this value is just not going to exist in memory, okay? This has no, our lambda has no arguments, all right? We're going to call this increment count C like that, okay? And what we want to do, let's just make it say what our number is, okay? So we'll do debug increment count, right, like that, okay? So we're going to see 0, then we're going to see 1, then 2, then 3, blah, 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 all the way until we get to 10. All right, let's run that. All right. Keep an eye down here. This is where we're curious. See what happens when it gets to 10. All right, and it stops when it gets to 10. All right, awesome. That's awesome. That's what we want. Let's make it when we mouse exit, we go the other way, okay? So we do the same thing. All right. We start at max num steps. And this needs, we're going to need another function that goes the other way. So void decrement count int C. All right. We'll just put that right here. All right. Remember, cursor is going to enter. Okay. Counter is going to go up. All right. Now, when our cursor leaves, counts down. Okay, rad. All right. Now, something that we can do is let's speed this up. Okay. And let's just make it so that I don't have to change these 500s to a bunch of different ways. Let's add a variable here. Float refresh rate equals, there are 1,000 milliseconds in 1 second, and we want this to refresh at 60 times per second. All right. We'll just put that here. Now, because this is such a simple lambda, we're just going to put this all on its own. All right, here we go. Let's check that out. Okay, this is going to refresh much faster. So keep an eye on how much quicker that goes. Okay, a lot faster. All right, so now what we can do, we can simplify this a little bit. We go like that. Get rid of this line. Same thing here. Basically what this says is first compare C with num steps and then increment it. All right. So now what we do, after we increment, we call repaint. All right. Does that make sense about how we do this one thing? A few milliseconds later, we're going to call this function again with a changed value. All right. So now what we can do is we can use this background color, we can modulate it, all right? So we know what our, what we need to do is make a local value, int current step, set this to 0, or, yeah, we can just actually, yeah, we'll set that to 0. Whoops. All right, we make a local value, and then every time that we call mouse enter or mouse exit, that's what's going to get changed. Okay, so when we enter the function, first we need to do current step equals 0, because we're going to reset. All right, and this is what we pass in. Current step, like that. All right. Now, if current step is less than num steps, all right, we're going to increment this. We want to keep track of, we want to make sure that current step is set to our latest value. So current step equals C, like that, because we're going to use current step here to adjust the color. All right, we'll do the same thing for mouse exit. We pass in current step like that. All right, and then for decrement count, you say current step equals C. If C is then we pass in that value right there. All right. So now what we can then do is we're just going to modulate our background color. We're going to go color C equals background color dot interpolated with some other color. And our proportion is going to be float. All right. It's going to be current step divided by num steps. All right. This needs to be a float. Okay. Just to kind of show what this looks like before we actually draw it, we'll do this. We'll do debug just to show the way the value changes. Like that. All right, now every time repaint is called, we're going to see some value between 0 and 1. All right. So before I do this, let me just get rid of these decrement counts, because we don't need to worry about whether or not those work anymore. We know that it works. Okay. So we're just going to focus on this. All right, here we go. Remember, we're looking for it to repaint and show the interpolation amount going from 0 to 1 whenever the cursor goes over. And sure enough, there it is. Like that, from 0 to 1 and back down. All right, cool. So now what we can do is use this background color dot interpolated with some other color. All right. Now our background color interpolated with, let's see, we want, right now this is, let's see, ARGB. So this is all red. So we're going to make it interpolate to blue. All right. So color 0x, full alpha, no red, full blue. Wait, no, that's green, RGB. There we go. All right, like that. Okay, so background color interpolated with this blue color. Now the way interpolated works with is if the value is 0, it's 100% background color. If the value is 1, then the color is 100% this color. All right, let's check it out. Okay, when I mouse over it, we'll see change. Now you'll notice that it's just changing, it's doing a fade out. Let's slow down that refresh rate first of all. Let's make this refresh 5 frames per second. So then we can actually see what's going on. And actually we'll make this refresh, we'll make it take 20 steps so we can really see what's going on. See if we can figure out this bug. Okay, something's weird. Something weird is going on. So the problem is because in our mouse enter we are changing what the background color should be. All right, so we get rid of those lines. All right, and here we go. All right, that was pretty neat, and we fade out and it goes the other way. All right, let's bump this back up to 60. Okay, we'll speed this up a little bit too. 10, like that. So it goes much quicker. All right, cool. So now, just to kind of show where this is somewhat useful, I'm going to make a bunch of these components and just randomly place them on the screen, and you'll see how it, how cool it looks. I'm also going to change this color a little bit. All right, let me do that and come back in just a second. All right, so we've got this implemented now. Let me show you what it looks like, and I'm going to explain some of the flaws that it has in it and whatnot, and also some things that it's good for and some things that it's bad at. All right, here we go. Okay, so here we have, we got a bunch of these little animated components, and if I mouse over one, fades out, mouse over another, fades out. All right, pretty handy. Okay, so now where this has problems is when you mouse over faster, if your mouse exit message happens faster than your refresh rate. So say you have like a mouse enter come in, and then let's say this, we'll just say this is 50. So that way our refresh rate is 20 milliseconds. So say our mouse enter happens. Let me pull this back up and pull this to the side. All right, say our mouse enter happens, and then less than 20 milliseconds later, our mouse exit happens. So what that means is that this lambda is going to fire 20 milliseconds after this happens, and then also this same lambda is going to fire at the same time. Or it's going to fire before, which means that our fade out is going to happen faster than our fade in happens, which means things get stuck, like you can see here. All right. Now in the next video, part 2, I'll talk about the other solution, and that's going to solve this problem. All right. This one will be a little bit easier. Just to, go full circle with regard to the implementation. The way this works is I've got a vector, I've got an owned array. Part of the reason behind having an owned array is that components are not allowed to be copied. If we go way down here, way at the bottom of component, ed vector, component, more comps. You can't do things like this. More comps dot pushback. We'll just add a component. Component. See, you can't do this. All right. Watch for the error message. All right. Called to deleted constructor of juice component. All right. So the way to get around that is we have to use an owned array. Oh, where are we? We're right here. We have to use an owned array that's going to hold a bunch of pointers to these animated components. So that's what gets created here. And then since I have a vector of these owned arrays, that's what's going on here. First I push back the owned array vector itself. And then in this individual owned array, I'm going to add the new animated component that I just created here on the heap. That gets pushed back into this owned array, right? And then that gets added here. And then regarding painting, I just, first I grab a single row like this, and then I iterate through each column like this. All right, and I just set the bounds as shown here. All right, I hope you enjoyed that. Thanks again to the audio programmer for letting me do a guest post on his channel. You can check out my channel, Matt Cat Music, where I have like a few other of these music-related programming-related tutorials, but for the most part, I just focus on doing regular music-based stuff. Anyway, I hope you dug that. Stick around for part 2, where I'm going to actually explain the better solution than this. This works really well if you just need singular stuff, but if you have a bunch of components, like shown here, and you need them to kind of, do that, this doesn't work so well. So I'll show the other solution in the next video. All right, thanks again. Later.